Hi, now we are going to discuss deterministic and non-deterministic. What do you mean by term deterministic and non-deterministic? I have taken two examples here. These are automata diagrams. So automata diagrams have this symbol symbolizes the state, the circles, and when we have the double circle, it implies final state. If we have an arrow and without any state behind, this means the initial state, and in the middle it is the transition state, transition phase, in which on applying an input which is represented on the top, the state changes from first to second. Okay, so this is an automata diagram, and first diagram says that from state 1 the state changes to final state, say F state, on applying input 0. So we know only one possible way to go. In the second case, in the second diagram, see, on applying 0 you can go here or here. One says that from state 1 I can go to final state and say this is F1, and second one says on applying 0 I can go to state 2, and then on applying 1 I can go to applying 1 I can go to state F2. So these are, since here we have a problem, we don't know whether to go on this one or this one direction. And when we are talking about a system or a computer does not know how to choose. Like I know by looking at this diagram, if I want the output to be 0, 1, I'll select this route. If I want that output to be 0, I'll select this route. But computer cannot understand that. So this is called deterministic. This is called non-deterministic, where we're not sure how to solve. So let's understand how this is related to our P, NP, or any kind of problem. Consider sorting problem. Sorting problem. I have like 1, 2, 3, 7, 8, 9 numbers, and say I'm solving using a selection sort. So what does the selection sort say? Selection sort, they select the maximum and put it in the front. So here when we are talking about maximum can be only 1. That means out of this only 9 is the maximum. I cannot say 8 is also the maximum. There's only 1, right? So this is called deterministic approach. And when we are talking about, say, numbers from range 2 to 8, and when we are talking about a range, this is not deterministic because it could be 2, it could be 3, it could be 7, it could be 8, considering 2 and 8 both inclusive. So there are multiple options for this. That I want to swap the maximum number from the first value. It's fine because 9 is the maximum. I'll just of the index, I'll swap their positions. But when we're talking about numbers from, say, some range 2 to 8, there are 4 numbers. Now computer gets confused which exact number I need to swap. So this is a non-deterministic approach. Say, this is not the automata diagram. This is the nodes represent cities, and these are the routes. And say some A, B, C, D, E are the cost. So from reaching city 1 to city 2, and if I take this route, it takes A time, or sorry, A cost from 1 to 2 directly, route. But if I talk about route 1 and say this is 3, and then 2, the cost would be P plus C. And here it is, say, 4. And to reach, so traveling salesman problem says that, there's a traveler. He has to visit all the cities and with minimum cost possible. So we want to minimize the cost. Now this problem has an issue because there are multiple routes possible. Deterministically, we cannot solve it, but non-deterministically, we can solve it. That means we can try from all the options and we can see which is the best. Okay, sort of like a brute force approach. But this kind of a approach has a cost of 2 power n, order of 2 power n. This kind of an algorithm has a time complexity of 2 power n. So it becomes a non-deterministic approach. We'll discuss about P and NP problem. I hope you're clear with deterministic and non-deterministic, because this is the basis for P and NP problems.